All right, welcome back. Today we're going to go over Amazon Rekognition. But before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Rekognition, the visual intelligence for the modern application. In our image-saturated digital world, the ability to automatically understand and analyze visual content has become crucial for modern applications. Amazon Rekognition transforms this challenge by providing deep learning-powered computer vision capabilities that can identify objects, recognize faces, detect text, moderate content, and extract meaningful insights from images and videos without requiring specialized machine learning expertise. Okay. Rekognition represents a significant leap from the traditional image processing tools. Using deep neural networks trained on massive data sets, it can understand visual content at multiple levels, from identifying basic objects and scenes to analyzing complex activities and detecting subtle patterns. The service handles the entire spectrum of visual analysis tasks that modern applications need: object and scene detection, facial analysis and recognition, text extraction from natural images, content moderation for safety, celebrity identification, custom object detection for specific business needs, workplace safety monitoring through PPE detection, and anti-spoofing through face liveliness verification. This comprehensive approach means you can build sophisticated visual intelligence into applications without the traditional barriers of computer vision expertise, model training, or infrastructure management. Amazon Rekognition provides pre-trained models that work immediately, while also offering customization options for specialized business requirements. Okay, so integration with all right, so Rekognition operates as a part of the broader AWS ecosystem designed for scalable, intelligent applications. Images and videos typically reside in S3, making them immediately accessible for analysis. Lambdas automate workflows based on Rekognition results, enabling real-time responses to visual events. Amazon A2I provides human review capabilities for sensitive moderation decisions, ensuring accuracy where stakes are high. And then step functions orchestrate complex pipelines that combine multiple AWS services, while Amazon SageMaker enables advanced custom model development when standard capabilities need enhancement. And CloudWatch Monitor usage patterns and performance metrics are monitored, while IAM provides fine-grained access control for both Rekognition APIs and underlying S3 storage. This integration creates a seamless environment where visual intelligence becomes a natural component of larger application architectures. So we're going to go into the console and get a little familiar with this. Let's try the demo. Let's see. We have the test image here. And you can see the labels that are here: person, building, car, right? Skateboard, right? So observe all these labels, and you can see that it's pretty confident in what it's identified. And I think you can be as well. So this demonstration uses the Detect Labels API. This basic object detection demonstrates how Rekognition identifies and categorizes visual elements with confidence percentages, which you see over here, right? This provides the foundation for searchable media libraries and automated content organization. Then there's content safety through moderation. So let's see. Why am I not seeing it? That's the request. That's the response. Moderation. Okay. Okay. So we can view the content here. All right. So this is where you can add an image, or you can see this test image. And this will blur this and suggest labels such as this is suggestive, this is violent, this has explicit nudity, and it has confidence scores as well. Well, since nothing here is objectionable, it won't. And you can integrate this with the A2I for borderline cases that require human judgment. And the content moderation capabilities enable automatic filtering for user-generated content platforms, ensuring compliance with community standards and regulatory requirements. Then you have facial analysis, right? So from here, you can upload an image, you can upload an image, or you can use the one that we already have here. And then this will put out outputs like the gender estimation, the age range predictions, and the emotional state detection, right? So it looks like face appears to be female, age range, smiling, right? Appears to be happy, wearing glasses. Okay. And then understand that these confidence scores inform decision making in identity verification services. So the facial analysis enables applications ranging from demographic analytics to security systems and personalized user experiences. And within this, there's a celebrity recognition. All right. So I think a lot of people know who this guy is if you're watching this. So this can do the same, upload, or you can drag and drop, right? And it can observe and return a name, which you see here, right? With a confidence level, okay, to identify celebrities. And this feature only works for individuals in Amazon's celebrity database. And celebrity recognition supports media monitoring, content tagging, and automated content categorization for entertainment and news applications. And then let's see, text extract. Okay, so here's another. Okay, so you can also upload, drag and drop, and this will analyze the text in an image, which you see on the right says it's Monday, but keep smiling, right? So this can assess the accuracy across different fonts, sizes, and backgrounds, and it can understand the use cases from document digitization to accessibility features. So the text detection transforms the images containing written content into searchable, processable text data. And let's see. Um, let's see. Well, this isn't exactly image properties. That's pretty useful. Um, let's go PPE. Okay, so this would be for workplace safety. All right. So in the same one, you can upload or drag and drop, and you can see the detection of like a face cover, head cover, gloves for hand covers. All right. And this is for an application for automated safety monitoring in an industrial environment. So this is PPE detection, and it enables automated workplace safety compliance without human oversight. All right. So let's go back over here. Okay, so you can do a lot with business specific needs. Let's see. Um, let's try this. Let's get this. Yeah. All right, let's do custom labels. Okay. So Rekognition has pre-trained models that handle common scenarios, but businesses might require specific objects, logos, or concepts unique to their industry. So custom labels can give you the functionality to address this by enabling training on your own label data sets. So for our custom labels, get started. First time setup requires an S3, store this. So create the S3. I already have S3s. Why does it require this? Okay. All right, and there's a tutorial. All right. And what you want to do, let's go to projects. Okay, you create a project. All right. Let's say test, create that project. All right. And then from here, you provide the training data set. Start with a single data set, or do you want to do a training data set and test data set? Let's just do this. We can import this from an S3 bucket. We get the S3 URI, so we have to go over to S3. Okay. And then what's the URI? Okay. Why am I not seeing that URI? That's the ARN. Oh, I would have to go. Hold on, let me go back. Oh, no, copy the ARN. That's not what I want to copy because this is asking for the S3. Enter the S3 URI. Yeah, copy URL. No. Share the pre-signed. No. Why am I not seeing this? Um, actually, don't specify an encryption key. No, we don't. We're just practicing on this, so we don't need an encryption key. Let's go in here. Okay. Hmm, folder. Copy URL. Let's see this. So, there we go. All right, so here we go. It's S3. This is where it would be. Automatically assign image level labels to images based on the folder name. Yeah, so we could go ahead with this, and you can see, the labels like golden retriever, collie, right? Make sure that S3 is correctly configured. So this means I have to copy the policy below, right? Apply this, which we're not going to do. I just want to give you like an overview. Okay. Then you can start labeling the images. You can train your model, and you can evaluate it. All right. This is just to give you a very broad overview. We're going to get rid of that though. Delete. I just don't want artifacts that are going to cost me, or resources and artifacts that are going to cost money. All right. So custom labels can transform the generic computer vision into business-specific visual intelligence for your dog grooming business or your hair care business, right? And it enables the recognition of proprietary products, unique safety equipment, specialized infrastructure, or industry-specific visual patterns. Okay. All right. So these are some resources. We just went over custom labels. Security. Okay. So Amazon Rekognition operates within the AWS's comprehensive security framework. This requires appropriate IAM permissions for different operations. And essential permissions include detect labels for object detection, detect moderation labels for content safety, compare faces for facial comparison, start label detection for video analysis, and comprehensive S3 access for uploaded content. This permission structure enables fine-grained access control where different application components or user roles can access only the specific recognition capabilities they require, supporting both security best practices and compliance requirements. Okay. And pricing. So recognition pricing reflects its usage-based model, with image analysis starting at 1/10 of a cent per image for the first million images monthly. Video analysis costs approximately 10 cents per minute, depending on features used. And custom labels training incurs $1 per hour charges, while inference costs 10 cents per image. The transparent pricing enables predictable cost management and scales economically for prototype through production development. Okay. And you can see some scalability using APIs to be able to run this effectively. You can do that, right? Because realistically, Amazon Rekognition will enable applications that were previously impractical or prohibitively expensive, like social media platforms. They use content moderation to automatically flag inappropriate material while routing borderline cases to human reviewers. Retail organizations implement brand monitoring to detect logo appearances in user-generated content. Financial services might leverage identity verification by comparing selfies to official documents. And manufacturing companies would automate workplace safety compliance by monitoring PPE usage in real time. So, media companies create searchable archives from vast video libraries, enabling content discovery and reuse. Security applications implement facial recognition for access control while maintaining privacy through local processing. And e-commerce platforms will automatically tag product images for improved search and categorization. Recognition really democratizes computer vision by removing the traditional barriers of specialized expertise, infrastructure management, and model training. So whether you're building a safety monitoring system or creating accessible content or implementing intelligent media workflows, Rekognition can provide a visual intelligence foundation that can transform static images and videos into actionable business insights. Anyways, we're done, and we're going to go take a little break. But before you go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.